Okay, hello. So welcome to the Curse Your Bones Availability Zones session. So my name is Craig Anderson. I'm a principal cloud architect at AT&T. The target audience of the session is OpenStack providers that want to understand availability zones, how to get the most out of them, and associated challenges. So the first half of the talk will get into the implementation, for the first half we'll cover the availability zones and the kind of the abstract and the high-level criteria for designing and organizing them. And then the second half will cover the more of the low-level details of the project-specific implementation in OpenStack. And then just the last thing before we get started, I'm going to use AZ as a shorthand for availability zones. So throughout the talk, and each reference is going to save me 5 syllables, and trust me, they'll add up. So what's an AZ? Start with the basic question. Quite simple. So, the simple answer is it's a failure domain within a region for your cloud application or your cloud applications. And like many things in OpenStack, the original concept comes from AWS, which is shown on the right. So the idea that is that you partition your hardware to protect against certain failure scenarios, and the tenant deploys their workloads across these failure domains to achieve higher application availability. Now, I'll also mention there's a few other ways which people have found AZs useful in OpenStack, and we'll look at a few of those in a bit, but for now we'll consider AZs in terms of failure domains. So how do you organize your AZs? Planning your AZs usually begins by identifying single points of failure in your data center. So this example shows AZs defined by power source. We have 2 racks of servers connected to the first power source in AZ1, 2 more connected to a second in AZ2. Then your tenants would have their cloud apps deployed across both AZs, for example, primary and a backup. If one AZ fails, then the tenant VMs in the other AZ take over. So another example, let's say that your server racks have only a single top of rack switch, and maybe so each TOR is then a single point of failure, and then we make each rack its own AZ. And here again we see the same cloud app, configured with the primary and the backup. I also show here an app that deploys with a quorum that spans 3 failure domains, and for a single region, which is what we're talking about here, that's typically all a tenant will need for high availability, which is 2 to 3 failure domains. But as we add more racks, we're going to get more AZs. So if we have 12 AZs, then tenants are going to have to choose 2 or 3 to use out of 12. Unfortunately, they can't say, schedule my app to any 2 AZs out of the 12 that have capacity. They don't have the ability to do that in OpenStack. And neither can they interrogate the AZ to determine the available capacity within it. Because tenants aren't supposed to know how much underlying infrastructure you have in the cloud world. And this means they have no choice but to guess which AZs to use and hope they guess correctly the AZs with enough capacity. So the more AZs you have, the more capacity management headaches you'll have for yourself and your tenants. So a better way to do this would be to divide up racks evenly between our AZs in order to minimize our resource islands and to keep things simple for tenants. So the diagram on the right depicts this. And note that also in this case we no longer have one single point of failure for the entire AZ, but rather each AZ is now a collection of single points of failure. And that's perfectly fine because any failure will still be isolated to one AZ, which is what we're shooting for. So the real value proposition for AZs, the trick here is, how often do these kinds of failures really happen, right? and how often do they fail in the way you expect they will. It's often difficult to get good data on these kinds of failures, and they're not always very easy to test either. It could also be that you don't have a convenient single point of failure which you can design AZs around. Many data centers already have power diversity wired to the rack, redundant power supplies, redundant TORs, and all the rest. Again, if that's the case, you might wonder if it's worth having AZs at all if you're not getting any tangible benefit from them. But there is another way in which they can help, and that's in the area of planned maintenance. So this includes data center activities like moving and upgrading equipment, recabling of servers, rebuilding a rack, HVAC, electrical work, all of that, anything that can cause disruptions like that. And then you have, of course, software updates like for the kernel, QEMU, security patching, OpenStack, and operating system upgrades. The chances are that these are the kinds of disruptions that are more frequent than the chance failing of some piece of hardware. So this is an area where the AZs can really show their value. But the catch is that these maintenance processes need to be able to take advantage of your AZs, and that can be tricky. In the first case, it may require working closely with data center personnel to make sure they understand how your failure domains impact them. In the case of software upgrades, you'll need a well-tested AZ-aware update strategy, which isn't necessarily trivial either. So I threw this here just to show one other way of defining your AZs, which is that you could go off some physical boundary like a room, a floor, or a building. There may be some utility here. For example, if you have your lease expires on some space that you're renting, or you have to move equipment around for some reason, and then this setup like this could benefit you. And one of the other things that this diagram is useful for showing is the limitations today with OpenStack, which is, namely, you can't have overlapping AZs. You can't create, 3 AZ tiers, like a room, a floor, and a building, and then leave it to the user to decide what level of isolation they want. And I'm not aware of anything comparable in AWS to this, but I just figured it listed here as a limitation regardless. And this just means you're forced to pick one consistent definition for how you define your AZs, and that changing the definition later, while it's not impossible, just be aware if you do, you may have to migrate or reprovision workloads so that they're properly placed within the new AZ definitions. And this is just the few other uses for the AZs, which we mentioned in the beginning, that I've seen people try to use AZs for. So you'll notice what they all have in common is that they don't really use the idea of the AZ as a failure domain. So instead, they're using the AZ mechanism to achieve another objective, but one which usually can be accomplished differently. So one thing I've seen people use AZs for is to let users choose between different cloud features, like I want to deploy in KVM versus VMware as like a target hypervisor. Other ways of doing this, you can set the hypervisor type in your image metadata, which dictates which images go to which hypervisors, or creating Nova flavors that map to your different hypervisor types. So the second, probably the most common one I've seen, are operators who want a private AZ for a special tenant or tenants. And besides not really being a failure domain, this doesn't really provide privacy or security by itself. Because AZs are public to all tenants. You can't hide an AZ from specific tenants. There's no RBAC built around them. If they're not meant to really function that way. If you have tenants that need to be in their own special hardware, for example, you can achieve this with using features like multi-tenancy isolation filter and private flavors. And the last one here I've seen is AZs defined for each compute host. So from an operator who wanted a specific set of workloads to run on each hypervisor, but again, you could do this using some mix of like affinity, anti-affinity filters, and the same host and different host filters in Nova. So, anyways, I would advise against using AZs in these ways, just because it's not going to align with the tenant expectations coming from cloud providers like AWS, who are expecting this just to be a failure domain and not, something more than that. And in the end, it'll probably be more trouble than it's worth putting a square peg into a round hole with these. So okay, now we can take a look at AZs in the context of OpenStack. So it's a bit of a challenge for cloud operators, since each OpenStack project implements AZs differently, if they implement them at all. These differences will be important to understand for the planning of your AZs. The time constraints being what they are, I've just selected 3 OpenStack components to look in detail at: Nova, Cinder, and Neutron. So to start with, Nova, each compute agent is mapped to an AZ, like so. When a VM is created, you can supply an AZ, and the VM is built on one of the compute agents assigned to that zone. So Nova AZs are just host aggregates that have the availability zone metadata set. In fact, that's all that's required to turn an ordinary host aggregate into something that Nova sees as an AZ. And note that the availability zone column on the left, or in the middle rather, shows AZ1 because we set the availability zone metadata on the right and not the other way around. So there are also 2 Nova AZs which are not actually host aggregates. There's a default availability zone where compute agents will live before they're placed into a user-created AZ aggregate, or where they will go if they've been removed from one. And it's set in nova.conf for Nova API. And this means it's a global setting. It's not something you configure differently for each compute node. And really all you want to do here is make sure that this doesn't match one of your other AZs. And also other Nova services like Nova API, Nova Scheduler, et cetera, have their own AZ called internal. And again, it just has to be set to a unique value, but otherwise has no practical function. And one general note with AZs for all of the OpenStack projects is that they only apply to services that directly impact the tenant workloads and not others like the API and scheduler services. So you can optionally leverage the same physical failure domains when deploying these services, but that will be up to your deployment tools to implement and not something that happens internal to OpenStack. A few other corner cases to be aware of. Nova will raise a 409 conflict if you try to assign the same compute host to more than one AZ. And that's part of the reason why we can't have overlapping failure domains mentioned previously. Also, you can configure a default AZ for scheduling if the user hasn't given one. However, normally you don't want to do that. So that you can accept workloads that don't require high availability. And in this case, Nova will schedule to any node with capacity regardless of the AZ. This helps with the resource segmentation issue, but only in that one case. It doesn't solve for picking 2 AZs out of the 12 to schedule a high availability workload. So one other useful Nova parameter is the cross AZ attach option. When it's set to false, it will only allow you to attach volumes that reside in the same AZ as your VM. So this can be useful for preventing tenant resources from spanning across failure domains when you don't want them to, and inadvertently compromising availability of those applications. It can also help if your storage networks are isolated between your availability zones, or if the volume performance would suffer with your cross-AZ attachment. So the storage architecture also can play a role there. A few other things to keep in mind, though, with this. Your Cinder AZs will have to match or align with your Nova AZs for this option to really work properly. And even when they do match, there are still edge cases where this doesn't work or can fail, and I listed 2 links to some open issues about that. But yeah, so now that we're on the subject of Cinder, we'll jump over to that, which is Cinder, AZs in Cinder. And in Cinder, each Cinder volume service gets mapped to a particular AZ, as we see here. And when a volume is created, you can supply an AZ, and it will be built on one of the volume services assigned to that AZ. This also shows a situation with multiple backends configured and choosing the SSD backend in this example. The backends here are seen to be in the same AZ as the Cinder volume service that manages them. So to define those AZs, we won't be using host aggregates because Cinder doesn't know anything about host aggregates. Those only exist in Nova. So instead, we define a config parameter or a set of config parameter that defines the AZ for each Cinder volume service. And like with Nova, we can't assign the same entity to more than one AZ. So that piece is the same. No overlapping AZs here either. The table at the bottom is just an example that shows the service entries for a SSD backend and their assigned AZs. So starting in the Pike release, we can also define AZs at the level of a storage backends themselves instead of one AZ for all the backends controlled by the same Cinder volume. This wouldn't really buy us anything in the LVM example here, but it wouldn't make sense to really split the failure domains for 2 different types of local storage anyways. But this feature could be more useful if you have one Cinder volume controlling several remote storage backends, especially when you don't have the ability to deploy Cinder volume directly into those remote AZs. Otherwise, I recommend grouping them together in the same AZ so that they fail together. So also, as with Nova, we can assign a default availability zone, which is used in the event that we don't get an AZ in the API request. The difference is you can't just leave this blank and let Cinder schedule to any AZ with capacity. If you leave it undefined, it falls back to the storage availability zone config option. And if that is undefined, it will schedule to a hard-coded default Nova AZ, which will fail if you don't have an AZ that matches that name. So if you're going to have more than one Cinder AZ, my suggestion is to set this to something like AZ missing, which is useful because it'll show up in the server logs and in the API response to the user. Personally, I prefer this over configuring a static default AZ just to avoid an uneven allocation of volumes. However, you might not need more than one Cinder AZ. And most storage appliances implement their own redundancy that exists outside the context of OpenStack AZs, or distributed storage systems like Ceph, which probably span all of your AZs anyway. In these cases, you can use the allow availability zone fallback option, and this can be useful for some of the flows in Nova, heat templates, and some of the other third-party client libraries that sometimes assume that they should create volumes in the same Cinder availability zone as the Nova availability zone used for VMs. Otherwise, the API requests to create the volume can fail if it's an invalid, Cinder considers it an invalid availability zone. So the next one here is Neutron. And AZ support in Neutron exists for DHCP and L3 agents. Prior to this, there was HA, but it wasn't AZ aware. So previously, if we had 2 DHCP agents and they're configured to host, or rather 4 DHCP agents and they're configured to host tenant networks on 2 of them, then the network could be hosted on any two agents which were available. But these agents could have been in the same failure domain, so now after you update your Neutron server configs to use the AZ wait scheduler driver, Neutron will try to schedule with AZ diversity. Also, one of the other things to note here is that because AZs are specified as scheduler hints in Neutron, you can chain them together as shown here. The story is basically the same for the Neutron L3 agent. A tenant router created with high availability would be hosted on multiple L3 agents. And again, Neutron will prefer to assign L3 agents with AZ diversity in mind using the AZ router scheduler driver. So for setting up the AZs, again, there's no host aggregates here. This is just setting a config in the option in the agents, or AZ config option in the agents file. And again, we can't have agents belonging to more than one AZ, so no overlapping AZs. And again, we also have the notion of a default availability zone in case the user doesn't provide the AZ information. But Neutron also lets you can list more than one AZ there, or AZ candidate. But if you're just going to list all of your AZs as candidates, then you can leave it blank and it has the same effect. The AZ scheduler driver will try to diversify the AZ placement regardless. And the other nice thing about leaving this blank is that your tenants won't need to provide any AZ hints, since Neutron can take care of the AZ diversity. And we can kind of see this by looking back at the initial DHCP example, and we leave the default availability zones undefined so that all AZs are eligible, and we need to have at least as many DHCP agents hosting the tenant network as the number of AZs with DHCP agents. Otherwise, you're in a situation where your network won't be hosted in all of the AZs, and the user will need to provide hints to ensure the network lands in the right ones. So that's why I recommend a config that simplifies the user experience, where they consistently don't need to supply any AZ hints here. So another interesting note with this implementation is that you're not guaranteed to get the AZs you ask for. And this can happen if the agents in the AZ are dead or admin down or have reached some other elimination criteria. So for this reason, it's a good practice to check your networks and routers after they've been created to ensure that they've been placed in the AZs that match what you've requested. Note that they won't actually get scheduled to an agent until you create a subnet in the case of a network, or attach a router interface or set a gateway in the case of the L3 router. A few notes on limitations. First, the L3 AZs are not going to apply for VMs that don't use the Neutron router, scenarios like provider networks and Neutron DVR with floating IPs. Also note that the AZ support does not yet exist for load balancing as a service, firewalls as a service, VPN as a service, but this is planned for the future, is my understanding. And lastly, your Neutron plugins are going to need to support the availability zones extension, and this support is currently limited to the ML2 and the L3 router plugins. So you're not going to have any luck with Contrail or other third-party plugins at this time. So in summary, this is a side-by-side comparison of the 3 AZ implementations we covered. I won't dwell on this since we already hit most of these items, but it may be helpful as a sort of consolidated future reference point. And the final summary here, why I think AZs can be hard to get right. They really touch every layer of the solution stack, which requires a high degree of knowledge and coordination between them. So just run down the list here. You have to have some understanding of your end user your requirements to ensure they can take advantage of what you're designing for them. You have to look at each OpenStack project, decide how you'll implement AZs for each one, or if you will, and then how to deal with corner cases and mitigate the limitations we just covered. You really want to have AZ-aware update and upgrade processes so that you can have AZ-isolated downtime during these activities. And unfortunately, that's usually not a trivial undertaking. Likewise, for any data center planned maintenance, having to drain or evacuate a batch of servers because a cabinet has to be rewired or physically relocated or powered down. You should have an idea how you'll leverage AZs in these scenarios. And then the design of your storage and network architecture also plays a role in your AZs. What types of resources can you share between AZs? What's kept isolated? What are the trade-offs being made between the performance, density, and availability in those designs? And lastly, having a good understanding of likely failure modes for data center hardware to inform your AZ planning. So that's a lot of things to balance together, and it's clearly a lot to consider. The last thought I want to leave you with is this, which is that if you're going to undertake the challenge of implementing AZs in OpenStack, then you should make sure you have something to show for it. There has to be a good business justification for what you're doing. Don't just use AZs for the sake of using AZs. Excuse me. Instead, build a case that demonstrates their value. Think in terms of unplanned failure and planned maintenance scenarios that we talked about. And only kind of after understanding how those fit in can you do the cost-benefit analysis to determine if using AZs is really worthwhile for you. So that about wraps things up. I wanted to thank everyone for listening, everyone who voted for the talk, and I'm happy to take any questions at this point. Mm-hmm.
How do you try to avoid hotspotting and everybody just picks AZ1 because it's there and it's first to the list?
Yeah, so that's an interesting question. Now, how Amazon deals with this is actually, this might be another good place to lean on Amazon for ideas, but the availability zones are different for everyone. So my AZ1 could be different than your AZ1. It's on a per tenant basis. So that would probably be the ideal way to resolve the issue. Really, the only other way is, asking your tenants, please, if you don't need high availability, just don't schedule to an AZ, and then Nova will just pick where it has space. But yeah, you'll still have that issue to some degree or other. Any other questions? Okay, well, thank you.